Thank you all for being here. The security is a dry topic, as well as I also understand this is afternoon, after lunch. So I'll try to be as interactive as possible. So what comes to your mind when it comes to talking about security, especially in web application? So say it again. Durability. And yeah, in terms of security. That's amazing. That's amazing. Yeah. So, older days, we have something called the password-based authentication, and we have a number of systems. If we had to log into multiple systems, we'll try to use same password or with little variations. And that worked on older days, but nowadays it's very difficult because now the world is driven by API, and passing the password will be very difficult, also very dangerous, because the APIs comes from internal organization as well as external organization. It could be from anywhere. So sharing password is not possible, and it's dangerous, and hence we have something called OAuth 2. So what it does is shift from password-based approach to token-based approach. The OAuth, in a nutshell, what it does is a short-lived token. Whenever an application sees a token, which thinks that, okay, this person is authenticated, this person is authorized to access this. Let's have this event as an example. So we have a card, we have the admission card here, and we are authenticated to be here. We are allowed inside the organization in the building, but we have a specific area where we can access. We can't access kitchen, we can't access a boardroom, we can't access secret places here around. Only public places being allowed. So all this possible in the OAuth 2.0. These kind of variations not possible in username and password-based approach because it needs a lot of customization, lots of DB storage and configuration, coding, all the stuff. So for example, if an API wants to access your Gmail, you can't share your Gmail account. You want to process your documentation, documents, Google document, you can authorize them to read-only access or write-only access or both based on the level of application requirement. So this is possible nowadays. So what it does is, what it takes for a third-party application is to register with a Gmail in advance. They will have a trusted identity with them. They are called client. And from then, you can see Google login, Facebook login, all the stuff for that particular application. So what it means is they have already pre-approved by the Gmail guys, Facebook guys, and whatnot. Simply it does is a federation of authority. You are authorizing the application to do something on behalf of you. So whenever you do something, the main application will ask you. For example, in this example, let's have a simple one. A Gmail, it will ask whenever you want to, say for example, nowadays it's AI. You want to edit your photo, and your photos are in Google Drive, and you are logging through Google. The AI application asks for your login. Where I can access? Okay, log in with Google, and it tries to access your drive. Upon supplying your credentials, Google will create a token that is something called access token. And before creating access token, it will ask for your consent. Hey, this guy is asking something like your files and photos, is that okay? And you'll say, yes, I only requested for that, go ahead. Then Google will create the access token. From that particular point onwards, the third-party application can just push the access token along with your request. So it is as simple as that. And it is short-lived. And after a few minutes, it will die. That's a concept called refresh token. We will come to that point later. So here, as you see, the sequence diagram, this is nothing but the actions what we spoke so far happening between the players. Totally here, there is a resource owner, there's a client, authorization server, a resource server. So resource owner, most likely it's a person. It could be you in terms of web application. And a client, what I call a third-party application, something creative. A vendor thought something creative. They want to do a photo edit software and they want access to your Gmail drive. And upon you log into that and clicking login with Google, they will send a request to Google. They will ask for client ID. The authorization server will ask for client ID, redirect URI, response type, scopes. Why they are asking? So I have given my consent. So without redirect URI, the Google don't know where I can talk back. So that is why the redirect URI. And the client ID, I want to verify you. Who are you? Whether you are registered with me or something, some outsider. That needs to be confirmed. And response type. So what kind of response type you want? There are different type of response type. And mostly we are going to talk about authorization code here, so which is commonly used. And finally, scopes. What level of access required? Read or write, or there are a lot of variations. I'm just talking about very basic one here. We can have n number of variations on the scope. So after this step, the Gmail sends a prompt to the user. That's a third step. And then the user fills a form and giving the password and also allowing to access the resource. So at this point, Google thinks that, okay, this is a valid request, and it provides an authorization code. That is the intermediate code, something like a one-time password. That's a very short period code. And that particular code, again, will be used by the client. The client here, again, I'm talking about the third-party software, and that will supply the authorization code along with the client ID. Also, there is something called client secret. When the client is registered with Google, they will need to have a client ID and client secret, which will be generated by them, and they'll need to keep that for their a transaction purpose later. And that is why the client is supplying client ID, client secret, and along with that, authorization code. The result will be the access token. So the access token is the ultimate door for external application or anyone. Anyone who supplies access token, they can access the resource, which is in the scope. Whatever the scope mentioned in the access token, they will be able to access. Any questions on this far? Okay, let's move on. Again, this is another variation of the sequence diagram. What is important here is what the authorization server requires. It needs a client ID, redirect URI, response type. In this case, it's a code, and along with that, scope and state. The state is something that can be skipped, but it is not a best practice to skip. The state is something which ensures that the call is verifiable and trustworthy, and it's secure. So the state is required as a best practice. So these states will be verified upon reception of access token by the gateway or your own software, that whether the state has changed or something, whatever the supplied state is still remaining, and hence it will proceed after that, after verifying the state. So for that purpose, we need to have the state. Okay, let's go and next slide. We'll talk about refresh token later. So simple example here. When I want to access a free code camp is a simple website where you can finish free courses. And when I log in with some popular logins like GitHub, Google, what they will ask is whether this person has an email and basic detail, what is his username. The result will be in this form. What needs to be carefully looked is under the scope, you can see user, email, and the state. State, as we discussed, it's a best practice to keep the system secure between the transaction. Okay, now so far we have spoken about OAuth 2.0 on authorizing systems, that will power the APIs and web application. A little bit about OIDC. Where comes the OIDC? Looks like the OAuth does most of the job. Why we need a OIDC? So OIDC is something like it needs, it does the authentication. The authorization part done by the OAuth 2, but the authentication still is it's not yet done. That particular bit is completed by OIDC. So how the OIDC does that? It will add another term called OpenID. When sending the scope, it will ask for OpenID. So whenever you say something like OpenID in the claims, you can say this is OIDC call. Sorry. So mainly what's the purpose of OIDC here? Say for example, you have multiple applications in your organization, and the user your employee needs to access a lot of applications. So that needs a lot of login. Every single travel request or timesheet, that needs a continuous login request. So to avoid that, so to push the SSO feature, we can include the OIDC implementation. So once the application has the OIDC, and once one-time login done, the OIDC system will take care of the token management and will keep it alive on the system with the user profile. If for the user is accessing a different application, that application will ask, hey, you have OpenID and profile? Yes. Then it will be active and the system is accessible. Again, there is a simple example. It is asking for example, if you see the second request from client to authorization server, it's asking for OpenID. So as a result, you will get the OpenID, and hence the authentication and authorization will go. The OIDC will implement the OAuth functionality as well. So together the authorization will also be done through the scopes. So here you are seeing one interesting thing, like a refresh token, why it's needed. So access token is only short-lived. For example, a few minutes. Consider you log into Gmail and after a few minutes just logged out. It's frustrating. So there is a concept called refresh token. So along with the access token, the refresh token will be sent upon a request, and the refresh token usually stored in the DB. Whenever the access token is expired, the authorization server throws an error, and automatically the API call will be made with the refresh token. Hey, I have a refresh token, so can you please send the access token? Then the system, again, the authorization server will generate access token, and again, it will generate a new refresh token, and it will send. The system will consume the refresh token and access token, will store the refresh token again for the future purpose. Again, this is a cycle, it will happen. Now, interesting stuff I tried, I haven't tried, it's just accidental stuff. I closed my laptop for quite a while, and a day or so. Then the Gmail was asking for password. Why? It's usually it gets logged in, right? Why it's asking? That is the refresh token's job. If I keep it alive and the polling happening between the server, then it will just move on. Again, this is another. So as you see, this one is a simple one. A client is requesting for a token. It will ask for the credentials. Upon supplying the client ID and client secret and other required stuff, the server identity provider will send the ID token. ID token mainly for the OpenID thing. So whenever there is an ID token, we can say this is for OpenID. And upon receiving the ID token, it will be supplied to the server to obtain required functionality. There is a concept called PKCE that can be supplied along with a token as well to provide additional security that we can talk later. So this is again simple example how medium.com authenticates for OIDC example. So as you see, the response type includes ID token, and in the scope you also see email, OpenID, and profile. The OpenID and profile is a part of OpenID, the OADC implementation. So whenever there is a profile is shared, which means that Gmail not only shares email ID, but also shares everything related to me, all the necessary details, my name, email ID, and all other details. So this is how we can differentiate whether this is a OIDC implementation or OAuth 2. OAuth 2 only have the access token. The OIDC implementation will have ID token. So little bit of playing around because the PPT is a little bit dry now. I will just click the less responsive. All right, lucky. So this is a simple website which demonstrates what's happening in terms of authorization code flow and OIDC, OpenID Connect flow. We'll see both of them. The rest of the thing, implicit and device code, is not a very popular one. So we'll see this one. As we see, when click the authorization code, it is asking for a client. Because I have not registered anything yet, I will need to register a client here. So I will register as a client. So the client ID secret auto-generated here. I will need to keep this thing with me. I will store it somewhere. This will be used in further logins. Okay. Okay, we are here. So, I have now login and password. So as a client, I need to build the authorization URL. So as you see here, I point to authorization server, what I need to done, authorize, and what kind of response code I want, code. What is my client ID? So just now we have created this client ID, and the redirect URI would be OAuth.com/playground. That something we have now, and the scope would be photo offline access. Offline access means it also supply, the server also supply refresh token. And as we discussed, this one have a best practice state here. So I am going to say authorize. Okay, I am being asked for username and password. I am going to give my username and password here. Approve. It is asking for the application OAuth 2 playground would like the ability to access your photos. Yeah, approve. So now we got a response, and it says, okay, because it's a playground, it says verify your state. I am going to verify. Yes, it's matching. Now we have got the authorization code. So where is the code here? This is a code. So this is a temporary OTP kind of stuff. We'll need to exchange that for an access token. I am going to give a final go here. So now the result is access token. This is access token. So with that, I can access the resource from the resource server. Yeah, this is a short demo for the authorization code. And let's do one more thing for OIDC. So again, same thing. I'll go for OIDC, build authorization URL, and as you see, it has OpenID, additional parameter. I'm going to give authorize. An application would like to connect to your account. Yes, sign in. So again, same state variable and similar flow, authorization code exchange. As you see, the grant type is authorization code here. This one is different. It has ID token. So this means it has additional detail. Along with the basic detail, it will also have a profile detail and other additional stuff. Let's try if it is something provides a meaningful stuff here by going to jwt.io. I have not tried. Maybe it won't because it's a playground, but let's see. Oh yeah, we have. So this one, the key which is used to sign, something called KID, and algorithm, what kind of algorithm used to sign this particular request. And as you see, the payload have all the claims. It says who issued the certificate, and the audience is something like the end application. This is something jagged content now because it is a playground, but usually audience is end client name. If someone we are creating a new application. That application would be AUD. These are the issued at expiry and common stuff here. As you see, the newly generated email also here. So these are something called the claims. It includes a registered claim and custom claim. Registered claim is something like ISS and AUD, IAT. These are the stuff reserved by JWT standard, which definitely needs to go, and there is no other content can go inside. And the custom things, we can have application-specific claims for us. So finally, the signature, it says two things, public key and private key. So what kind of key used to sign this is what it means. And usually, not usually, it has to. The authorization server will own the private key and public key. And the client or anyone who consumes that can have the public key and verify this is a legit request. For example, if you want to try that in the Postman, you will need to have a public certificate along with the access token in order to get expected input. Otherwise, it won't work. It will say certification error. That's what it means. Back to our presentation. Do you want to see another example? Yeah, great. Another example I would like to see is demo.yapili, which I felt very amazing because it does the real demo. For example, I am selecting the United Kingdom region, and what kind of operation I want to do? Data. What it means is any of the players who are registered with the Yapili or Yapili registered with these vendors, they can operate together. This is something called a thing called open banking. Open banking heavily use OAuth 2 stuff here. For example, I am going to take Monzo because I have a Monzo account. So it is asking me to do an authentication, which is something I can do. In order to authorize, I need to authenticate. The authentication done at Monzo side, which I am going to go and do. Continue. I'll need to do that again. Sorry about that. Okay, it is asking for a data. There was a pop-up. It says that the Yapili application wants to have your data. Do you want to go? Yes. I said yes. Now all my details are here. As you can see, this is my balance. And it's not even month end. Just fun. Okay. So this is what another demonstration about the OAuth, how that looks like, the authorization looks like. We'll skip the Monzo dev portal because we have seen Yapili stuff. We have discussed this. It has 3 parts, and the first one is header. We have seen the KID and algorithm used, and the payload. Payload usually have the claims. The claims could be the registered one, public and private. Registered one is something like ISS. The private or custom claims would include your application-specific claims. Finally, the signature. Signature nothing but is the public key information, public and private key information. And you can verify whether it's valid or not anytime using jwt.io. So these are the registered claims. As you see, ISS, SUB, subject is the user, the expiration and the issue date is something. These are the registered one. You can't use your data on this particular stuff. On the other hand, the custom claims, other way it's called public and private claims. You can use the data required for your application. For example, here it says a role for particular access token. This role is an admin, and upon receiving the access token, the application understands how this access token have admin rights. Okay, let's open the GitLab. Let's open this particular application. Yeah, that's how it works. And the difference between the ID token and the access token. As you see, what really differentiates OAuth 2 and OpenID Connect is just two things mainly, which is ID token and access token. This ID token is primarily for ensuring the authentication is alive across systems and ensuring the SSO. And access token, on the other hand, it makes sure that the resource is accessible for the given scope on different systems. So these are the bunch of terminologies. The resource owner is mainly the person who initiates the entire transaction, and the authorization server is mainly identity provider like a Keycloak, a Ping Federate, or Microsoft Azure AD, anything like that. And the resource server, it could be a separate server which serves the actual resource. For example, if I have to fetch a file, the resource server is that. When it is approached, it will automatically direct to authorization server, and authorization server will ask a question for whoever initiated the request. A redirect URI, as we discussed, it is a callback where I can come back once every verification done, where I can come back. If a client make a request, the authorization server expect this particular parameter to give a proper response, unless this won't work. So this is a mandatory stuff. Redirect URI is where the authorization server will send the response. And response type, what we have seen is authorization code. There are different stuff, things also there, PXE and implicit, those kind of response type. Scope is something where you will mention role-specific access. For example, an application, consider this GitLab. You have authenticated yourself, and your identity provider allows only certain people to have a certain access. No one can have all the access. Just the developer can have only developer access, and the maintainer can only have maintainer access, something like that. So how the granularity will happen? Through the scope. So the consent, as it says, whenever there is a request happen, the action taken by the resource owner, allow or deny. So physical action. Client ID and client secret is where we register our details, and in return we get ID and secret from the authorization server for the future purpose. Access token, again, this is something, a required thing to access API resource. And one thing we are missing here is refresh token that we have seen. It is stored in DB, and it's used for further communication and to refresh the access token to make sure we are accessing the content offline. Once it's authenticated and authorized, it's a free access That is what the refresh token facilitates. So these best practice also, a recommendation is we'll need to use a refresh token, and we'll need to store the refresh token in a secure way. We need to store the refresh token in a secure way because usually it is stored in DB. That DB cannot be plain text. You can't just store as is. It need to have its own process and security built in, otherwise it could be tampered. So we have briefly touched the scopes and permissions. The scope is what we ask for the authorization server. I need these things. These are the stuff, or the profile, email, and offline access. These are the stuff it will be there. And permission will sit on top of the scope. A scope is very granular. Permission is a higher level. Again, it is pointing to scope only. As we spoke about the refresh token, client secrets also needs to be stored properly in a secure environment, which is also a recommended practice. And for public clients, we need to also use a PIC-C certificate, as we discussed in the beginning briefly. We'll need to supply the certificate, need to implement the requirement for certificate, so to make sure it is not tampered. Yeah, this one also we have touched upon. The JOT token needs to be validated as well. So your gateway, something API gateway or these things needs to verify every token comes in. For example, the state needs to be verified by the API system, API gateways. That is a recommended one. Also, you need to have the short-lived token. The token revocation feature also needs to be there. Also, we'll need to have this monitoring system and maintaining these particular, whatever the token issuing and revocation, everything needs to be logged in and needs to be having an alert system whenever we have a repeat failure on the authentication and authorization operations. There are tools here. These are some of the popular libraries. For Spring Boot, we have Spring Security OAuth, and for Python, OAuth lib, and for Node.js, it's OpenID client. Along with that, we have other popular IDPs like Keycloak, Auth, and Ping Federate. Yeah, those are the general stuff. These are the useful tools. This include the playground detail. If you want to take a snap, feel free to do that. And the other learning resources. These provide a quick start on getting started with OAuth 2 and OIDC. Thank you. That's it for the conversation. 2 minutes left. Any questions?
Me?
Yeah.
I'm working in Civo, and in the latest months I needed to implement OAuth 2 and also OIDC from the server side, so not as a client. And I discovered how much this protocol is kind of elastic. So it was pretty difficult to understand how correctly implement, because if you read the documentation, you have some fixed points, like you have to have this /authorize, /token, etc. But there are some not well specified parts. For example, when you have to authenticate the user after the first call, after the /authorized, I needed to, for example, take the email or the password, and then I needed the team ID in my case, but it can be an organization ID. So I discovered how you can compose this protocol in the other part that are not well specified according to your needs. And in some other occasions, for example, I saw like some clients performing the token call differently. Some client is attempting to send back the code, so the temporary code, and sending the client ID and client secret with the X form URL encoded. Some others as query parameters. So I saw this kind of elasticity, so it's very variable, and also it can return you the token as header or in the body of the response. So what's your impression? Is there a correct way to do it? It's normal that you have a lot of variance. It's meant to be like that because there are different needs from the various organizations. So how to behave in front of variability? That's the question.
Okay, what I understood is your system supports multiple clients as well, is it?
We will have multiple clients, but now we have just Kubeflow as a service is our client. But of course, when I developed, it was meant to work with all the various clients, yes.
Okay, so there is something called well-known configuration that needs to be. So when you talk about a client and they are sending a different responses with inline to the OAuth standard, we all need to follow that OAuth standard. There is something called well-known configuration. This is the one. If you go there, it will talk about the well-known configuration for the particular provider. In your case, if you register with, for example, Auth 0, and you will have a domain. When you type this domain and well-known configuration, it will produce what needs to be, how the implementation needs to be there, what kind of scope needs to be generally, what needs to include, what are the mandatory stuff it needs to be there. So that will be shown for especially for your domain. Yeah. So if you could take this as a screenshot, that will be okay. Otherwise, I can talk to you later.
The welcome file, you mean, right? The one which is called the OIDC. The first call which is attempted to be performed is the /.well.
Yes, exactly.
And there is a summary of what can be the whole protocol so that the client knows what kind of. Okay. Understand.
Yes. Great. Thank you. Any other questions? Otherwise, it's a tea time. Let's all enjoy. Thank you so much.